So hello, this is a solution for mathematics AI HL, paper one, question one from the 2023 spring exam. So here we go. Question number one. It's worth 7 marks, so this is a lot of marks to get. So a player throws a basketball, and the height of the basketball is modeled by, and let's write this down, h of t equals negative 4.75 t squared plus 8.75 t and plus 1.5. And of course, that initial height here is going to be that 1.5. That's also the y-intercept of the quadratic. So this is a quadratic, and this is specifically projectile motion. So once again, player throws a basketball. The height of the basketball is modeled by h of t equals negative 4.75 t squared plus 8.75 t plus 1.5. T greater than or equal to 0 just means that time is positive and can't be negative, which makes realistic sense, actually. So h is the height of the basketball above ground in meters, and t is the time in seconds after it was thrown. Okay, so part A. Let's go ahead and solve it. So find out how long it takes for the basketball to reach its maximum height. And I think it's a good idea to do at least some of these problems by hand, I would think. And so the very first question, I'm going to use old-fashioned calculus. Old-fashioned calculus. So I'm going to take the derivative of the function and then set it equal to 0 and then solve for t. And then that t is going to tell me where that maximum value is going to be. So I'm going to do h prime, that's supposed to be a prime right there, h prime of t is equal to, well, now my derivative, it is a negative 9.5 t. 2 times negative 4.75 is negative 9.5 t, and then plus 8.75, and then plus nothing. The 1.5 cancels out. So there's my derivative. So what do? We take the derivative, we set it equal to 0, because we want to know where the tangent line to the curve is 0 or a horizontal line. That's going to indicate either a maximum or a minimum. In this case, the parabola is like the one behind me. It's upside down. And so therefore, it's going to have a maximum and not a minimum. So let's replace the derivative with 0. Is equal to negative 9.5 t plus 8.75. Move the negative 9.5 over to the other side, and we have 9.5 t is equal to 8.75. So t, let's find t now. Let's just plug it in, and t is equal to, what is it, 8.75 divided by 9.5 is going to be 0.921 0526 seconds. And hold on, let's also write this with the basic 3 significant figures. So t is equal to 0.921 seconds. And I think that's a pretty good answer. And if in the future I'm asked to use t again, I can use the t with the many digits. Probably 6 is enough, but I think I have a little bit more than 6 digits. 1, 2, 3, 4, 5, 6, 7. Yep. So that's the answer to question number 1. That is exactly where the maximum of the parabola, or the maximum height, is going to be at 0.921 seconds. All right, so let's go to part B. It says, assuming that no player catches the basketball, find how long it would take for the basketball to hit the ground. Okay, so now I'm actually back to the original function, the original parabola. And so when will it actually hit the ground? Well, keep in mind that the ground is going to be a time or a height of 0. So the h sub t is going to be a 0. 0 is equal to negative 4.75 t squared plus 8.75 t plus a 1.5. So I could, of course, do this one by hand, but I think what I'm going to do instead is I'm going to go to my calculator, to the GDC. And I'm just going to take my GDC, and I might already have it in there. There it is. So negative 4.75x squared plus 8.75x plus a 1.5. And my window should be set in such a way that matches this problem. So I've got an x min of negative 2. That's negative 2 seconds, all the way up to x max of 5 seconds. That's quite a few seconds for the ball to be in the air. X scale is 1, so every hash mark will be 1 second. Y min is negative 2, just a little bit below the x-axis. And let's say 7 meters should contain the height of that basketball. And Y scale is 1. And let's go ahead and graph it and take a look. There it is. So what I'm going to do is I'm just going to go ahead and take this graph, and I'm going to sketch it. Okay. So I'm interested now in where does that cross the x-axis. So I think I'm going to do that first, and I'm going to calculate the 0, just like so. And the 0 that I'm interested in is the positive one, because the negative answer, negative seconds, is going to be kind of bogus and irrelevant, I would say. So I get exactly 2 seconds. All right. So that value is 2 seconds. Right there. And 2 seconds is my answer. Well, I'm going to take a moment right now to also check the first answer. Remember, the first one I got was 0.921 seconds was where the maximum is going to be. And so that's going to be like an axis of symmetry of 0.921 seconds, but let's check it. Let's just make sure that that's actually the case. And what I'm going to do is calculate a maximum. Calculate a maximum. So I'll do the left bound, a little bit to the left of the max, and then a little bit over right, and let the calculator calculate the highest point. And the highest point is at 0.921 seconds. 0.921 seconds. And the height there is something they could ask us, 5.53, whoops, 5.53 meters. Okay, so that's going to be the maximum. So I'm just going to go ahead and just put this right here and say, oh, that's my maximum. And so I'm pretty confident now. I've been able to calculate the number of seconds as 0.921 seconds, and then actually use the GDC to verify that answer. So now I'm really confident. All right, so next question. Maybe I should actually answer this first. T is equal to 2 seconds. And by the way, there is another answer to this problem that's over here in the negative. And I think the negative is going to be irrelevant or unnecessary. Oh, and let me put my y-intercept. We know that the y-intercept is 1.5. So I'm going to put 1.5, and that's 1.5 meters. So let's go on now to question C. Another player catches the basketball when it is at a height of 1.2 meters. So maybe I'm not interested in when it hits the ground, but I'm interested in, well, when, because this is asking me when, right? Find the value of t when the player catches the basketball. So I'm not interested necessarily in 0 where it hits the ground, but 1.2 meters. So 1.2 is equal to negative 4.75 t squared plus 8.75 t plus 1.5. So I'm going to use the good old graphics display calculator to finish this question up. And I think what I'll do is I'll go to my grapher, and I'm going to graph the horizontal line of y equals 1.2. So that's going to be the horizontal line that goes right across here. Y equals 1.2. And so I'm interested in where that crosses or intersects the parabola. So I'm going to find that value. I already know the y value, so I'm also going to find the t value. So let's go ahead and graph that. And then I'm going to go to calculate the intersection of the parabola and the line. And so I get a value here, and the value is 1.875, 1.875777755, and the height, of course, is a 1.2. All right, so now I'm going to rewrite that answer over here for C. I'm going to rewrite it as t is equal to, let's go 3 significant figures. So just so you can see it, let's go 1.88 seconds. And there's another bogus answer over here that also is negative time, which doesn't really make sense for the question, but we're interested in positive time. Kind of set that at the very beginning, that time has to be greater than or equal to 0, or it has to be positive. And so 1.88 seconds is going to be that answer. And of course, we can see that I'm using the GDC. And that takes us to our last question. Write down one limitation of using h of t to model the height of the basketball. So, I thought about this one for a while, tried to think about some possible answers. And I try to think, how is the designer of this question thinking about this question? And I guess the best answer that I came up with for myself was this: once the ball is caught or held, once the ball is caught or held, h of t becomes irrelevant. So that's one possible answer for a limitation. Another one I was thinking of is like totally thinking of the physics, of a basketball going up in the air. And one limitation is that, well, let me put limitations right here. Would not account for win or spin of the basketball, and I'm actually thinking more of a lopsided type of basketball, which is maybe not going to take that really nice parabolic arc motion or that upside down parabola. Maybe it's not going to take that kind of motion if it's lopsided or if the wind is pushing it or things like that. That would be a totally physics type of an answer. Like we're assuming that the motion is going to be perfectly parabolic. Another possibility, and I don't think this is a very strong answer, it's why I put it last, but doesn't account for negative answers. All right, so that's what I came up with. I don't know if that's like the best possible solutions or not, but there you have it. And my solutions to that question are here. I hope that this was somewhat helpful, maybe even enjoyable. But I hope that you have a very good day. Thank you so much.